The Starship and the gigantic Super Heavy booster by SpaceX will return to the launchpad. Interesting, isn't it? Hey people, welcome back to our channel. In today's video, we will be looking at everything you need to know about the Starship and the Super Heavy booster of SpaceX. But before we start, be sure to hit the like button and turn on the post notification to stay tuned to more of our content. Done? Let's dive right in. The Starship system is an entirely reusable, two-stage to orbit super heavy lift launch vehicle which is under development by SpaceX as of August 2021. It is the world's tallest and most powerful rocket ever built by mankind, with more than twice the thrust of the Saturn V. The system includes a booster stage named Super Heavy and a second stage which is also called Starship. Unlike a traditional launch vehicle second stage, the Starship's second stage is being designed to also serve as a long-term cargo and passenger-carrying spacecraft, as well as a lander to transport cargo and crew to the surface of the planets and satellites such as the Moon and Mars. Both the stages of the launch vehicle are designed to be able to be recovered and reused. The Starship system development started in 2016 as a self-funded private spaceflight project by SpaceX. This was 4 years after work began on the Raptor rocket engine that powers both stages. Flight testing of the Starship second stage started in 2019, with slower launches and landings, and extended through high-altitude descent tests into May 2021, when Starship SN-15 became the first prototype to successfully complete a high-altitude test flight and be recovered entirely. The Starship system is built to carry passengers and cargo to places including low Earth orbit, the Moon, and Mars. It is a major part of the SpaceX's mission to establish a permanent human presence on Mars. Both the Starship's upper stage and the Super Heavy booster stage are built using a stainless steel hull 9 meters in diameter. In April 2020, NASA chose a modified Starship system as one of the 3 potential lunar landing system design concepts to get funding of a 10-month-long initial design phase for the NASA Artemis program. On 16 April 2021, NASA contracted SpaceX to develop a modified crew-rated Starship vehicle to serve as a lunar lander in the Artemis program. As of September 2019, the Starship upper stage is expected to have a 9-meter diameter, 50-meter tall, capable of being a fully reusable spacecraft with a dry mass of 120 tons or less. It is to be powered by 6 Raptor engines, 3 Raptor 2 engines, plus 3 Raptor vacuum engines. Starship is designed with the ability to re-enter Earth's atmosphere and retro-propulsively land on a designated landing pad. Landing reliability is projected by SpaceX to be by the end to be able to achieve airline levels of safety due to the ability to fly with one engine not working. The spacecraft is also made to be capable of performing automatic rendezvous and docking operations and on-orbit propellant transfer between starships. Starship is also made with the goal of reaching planets and moons in the solar system after propellant loading, while retropropulsion is intended to be used for final landing maneuver. 99.9% of the energy dissipation on Earth re-entry is to be removed aerodynamically, and on Mars, 99% aerodynamically even with the much thinner Martian atmosphere, where body flaps are used for altitude control using descent to evaluate both trajectory and energy dissipation. As shown in the 2017 design revealing, the Starship is to have a pressurized volume of approximately 825 metric cube, which could be configured up to 40 cabins, large common areas, central storage, a galley, and a solar flare shelter for the Martian missions. In 2017, SpaceX mentioned the possibility of using Starship to transport passengers on suborbital flights between 2 points on Earth. Any 2 points on Earth could be connected in less than 1 hour, providing commercial long-range transport competing with long-range aircraft. SpaceX, however, revealed no concrete plans to pursue the 2-stage Earth-to-Earth use case. Over 2 years later, in May 2019, Musk mentioned the idea of using a single-stage Starship to travel up to 10,000 kilometers on Earth-to-Earth flights at speeds approaching Mach 20 or 25,000 kilometers an hour with an acceptable payload, saying it dramatically improves cost, complexity, and ease of operations. In June 2020, Musk stated that Earth-to-Earth test flights could start within 2 to 3 years. That is 2022 or 2023, and that planning was happening for floating super heavy class spaceports for Mars, Moon, and hypersonic travel around Earth. In April 2021, SpaceX COO Gwen Shotwell clarified that she was optimistic that SpaceX will be flying large numbers of people on Starship within 5 years, including point-to-point transportation between 2 locations on Earth. Coming to the further details of the Super Heavy, as mentioned earlier, Super Heavy is a Methalox rocket stage intended to serve as the first stage of SpaceX's entirely reusable Super Heavy lift launch vehicle, Starship. It is 70 meters tall and powered by 29 Raptor engines on initial flight and 32 engines later this year. As of May 2021, the first launch of Super Heavy and the first orbital flight of the Starship system as a whole is planned for later in 2021. Super Heavy started its development as a first stage for the Mars Colonial Transporter, or MCT, a new concept designed to replicate the cancelled rockets Falcon X, Falcon X Heavy, and Falcon XX. The MCT first stage work was later replaced by development for the Interplanetary Transport System, or ITS, and the Big Falcon rocket, or BFR rockets, first stages. After the cancellation of the ITS and BFR programs for the Starship program, SpaceX started its work on the Super Heavy booster stage. Manufacturing of Booster Number 1, or BN1, which is now renamed as Booster 1, began in autumn 2020, with stacking of the first prototype completed in March 2021 in the High Bay Vertical Assembly Building at the company's South Texas launch site. Back then, SpaceX CEO Musk announced that BN1 was a production pathfinder, a prototype or testing unit not to be used for flight testing, but used to determine how best to produce future vehicles. Instead, BN1 was removed in favor of moving forward with BN2, with the goal of having BN2 on the orbital launch pad before the end of April 2021. A second unit, called B2.1, was scheduled to fly in June 2021. But according to NASA Spaceflight, both BN2 and B2.1 were reclassified as test sections in May 2021. In the beginning of June 2021, B2.1 was transported to a launch pad to undergo stress testing using hydraulic rams. The third Super Heavy booster iteration, BN3, now called the Booster 3, was planned to launch Starship SN20 in the Starship orbital test flight. It will now be using Booster 4, previously called BN4, which started development in July 2021. It was moved to High Bay on the 3rd of July. The Booster 3 moved out to suborbital Pad A on July 1. Although Super Heavy is built to be reusable, SpaceX planned to have Booster 4 splash down in the Gulf of Mexico instead of fully testing its landing system. The company intends to fly additional orbital flight tests pairing Super Heavy Booster 5 with Starship SN21, Booster 6 with SN22, and Booster 7 with SN23. Ever since then, SpaceX has been working hard to integrate its massive Starship spacecraft and the gigantic Super Heavy booster and place them on the launch pad. But not long after the two were put together for the first time, Starship was removed from the launch pad and taken back to the High Bay facility. Speculation spiraled about the reasons for removing the spacecraft from the launch pad so quickly after it was assembled there for testing. SpaceX basically removed Starship 20 from the launch pad on August 12, but Super Heavy Boosters 4 remained there for a few more days. A closer look suggested that the boosters remained on the launch pad due to high winds. Recently, SpaceX CEO Elon Musk replied to a tweet that showed a video of the Super Heavy Booster 4 being taken back into its production site in the beginning of this week. In that tweet, Musk mentioned that the booster and Starship would return to the orbital launch pad on Monday, depending on the winds. As an answer to why Booster and Starship were removed from the launch pad, Musk says that SpaceX needed to finish small plumbing and wiring work and that those tasks were easier to be finished off in High Bay. SpaceX did remove the 6 Raptor engines from Starship 20 after it returned to the facility in preparation for a test campaign that was to start on Monday. The Super Heavy Booster 4 had 29 Raptor engines inside it, which SpaceX started removing once it returned to High Bay. As one might imagine, moving 29 Raptor engines from the booster is quite a task. Reports show that over 12 hours after the removal process began, technicians are also inspecting the heat shield of the Starship 20 and preparing or replacing broken, chipped, and loose tiles. The removal of defect or damaged tiles began on 12th of August. The process is difficult due to the need to prevent damage to adjacent tiles and is to be done with care. With that, we are at the end of the video. Which is your favorite SpaceX rocket? Let us know in the comments below. If you found this video interesting, be sure to hit the like button and stay tuned. See you again with another interesting video. Until then, goodbye.